Lab 8, Experiment 2, Virtual Report by Amber Connolly. Experiment 2, Effective Temperature on Enzyme Activity. Hypothesis. I predict that the change in temperature will cause the reaction of the yeast in the hydrogen peroxide to slow, producing less gas. Materials. For this experiment, you will need 250 milliliter beakers, a test tube rack, 3 test tubes, yeast, 3 balloons, measuring spoons, hydrogen peroxide, 20 centimeter string, thermometer, permanent marker, ruler, tap water, a heat source, either a microwave or a stove, and a stopwatch. Process. Step 1. Use a permanent marker to label 3 glass test tubes 1, 2, and 3 and place them in the test tube rack. Here's a picture of mine that you can see I've labeled them 1 through 3. Step 2. Fill each of the test tubes with 10 milliliters of hydrogen peroxide. Then keep test tube 1 in the test tube rack at room temperature. Place the test tubes 2 and 3 in 2 separate empty 250 milliliter beakers. Set aside test tube 2 and place test tube 3 in the refrigerator. Below you can see the pictures of my process here. Step 3. Wrap the string around the uninflated balloon and measure the length of the string with the ruler. Record the measurement in the table. Step 4. Create a hot water bath by using the stovetop or microwave to heat the water. You're going to want the water to be 85 degrees Celsius. Any hotter than that and you'll end up making the hydrogen peroxide not do what it's supposed to do. Side note, I had to also switch to my mother's at this point because the power did go out. Step 5. Place tube number 2 in the hot water bath. Step 6. Let test tube 2 sit for a minimum of 15 minutes in the hot water bath, and test tube number 3 a minimum of 15 minutes in the refrigerator. It is okay if test tube 3 sits longer, but you do not want the hot water bath to get cold before proceeding with step 7 for that sample. And I did end up making test tube 3 sit in there for at least 30 minutes because I was doing everything else. Step 7. Measure the temperature of the hydrogen peroxide in test tube 1 by inserting the thermometer into the solution for 1 minute and record the temperature. Step 8. Measure 1/4 teaspoon of yeast and add it to the balloon. Carefully attach the balloon containing the yeast and to the top of the test tube in test tube 1. Start the stopwatch as you quickly dump the yeast into the hydrogen peroxide solution in the test tube and swirl it to mix it. It is important to execute this step quickly so that every bit of gas produced will be captured. Below you can see the various examples of this. I do have 2 different color balloons, the purple one being filled up in one picture and the green in the other. That is because I took them as I went and I ended up jumbling up the process. Step 9. After 1 minute and 3 minutes, gently wrap the string around the center balloon. I meant to say at 3 minutes, gently wrap the string around the balloon to measure the circumference. Make sure that the balloon does not pop off the tube as you do this. To obtain the circumference, lay the length of string over the ruler and record your measurements in the table. Step 10. Repeat step 7 through 9 for the other 2 test tubes. Here is table 2. I just copied and pasted it from the lab stuff that I had to turn in. As you can see, the hydrogen peroxide temperature for the room temperature was 20 degrees Celsius. And it ended up producing a balloon of 17 centimeters. Hot was at 40 degrees Celsius and produced a balloon of 17.5 centimeters. Cold was at 8 degrees Celsius and produced a balloon of 16.8 centimeters. Overall, the results. The results of this were that the temperature did have an effect on the reaction and the gas production of the solution. Heat produced more gas and cooler temperatures produced less gas. We used room temperature as a control, and it was in the middle of the 3 results, making it the even ground of judgment. Thank you.